All right. Today we have ourselves an iPad mini that's in here for a charge port replacement. The only time you ever want to replace a charge port on any iPad, because the iPads after the iPad 4, such as like the iPad Air and iPad mini and so on and so forth, are all soldered on. I think one of the new ones actually has a modular one. I think it's a Pro. Might be wrong there, but in this case we have an iPad mini and the charge port is soldered onto the logic board. And the charge port is essentially nothing more than just wires. And the only reason you would ever replace the charge port in one of these iPads is if there's physical damage. If you look inside of the charge port underneath the microscope and it looks perfectly clean, don't replace the charge port. That's just going to be a waste of time. Your issue is either going to be with the battery or with the charging circuit somewhere on the iPad itself. This one I've already taken a look underneath the microscope, and it does have some corrosion and some bented pins. I'll show you what I see in here. So if you look on the sides, we do have some corrosion, and that middle pin right there looks to be pushed down. So I'd say this qualifies for a charge port replacement. I've already taken the liberty of hooking it up to our USB ammeter just to verify that it doesn't charge, and it does draw 0 amps, no amperage at all. This one did come from another repair shop, so they have already taken the time to remove the screen for us. It is adhered down just a little bit. We should be able to open this one up fairly easy. So let's get to it. So we'll use our heat gun to go around the sides of the iPad to evenly heat up the ambient temperature. Then we'll apply some heat up here to the top to weaken the adhesive as we open this up. And there is a film protector on here as well. I'm not sure if that's going to affect our heating process. I don't think it will. I think the most it'll do is potentially bubble up. So this has been opened up before because the adhesive is just sliding through like butter. Awesome. Yeah, that came off fairly simple. Now we'll need to remove the screws that hold the LCD down in place. And it looks like someone's already removed the LCD in the past, so it should come out of this housing fairly simple. I'm assuming what happened is it wasn't charging, so the other repair shop had already taken this apart to try a battery first. And I believe that's how they came to the diagnosis that the charge port was the issue. So normally with the iPad mini, you have adhesive all along the two sides right here, and then on some of them, like the Retina, the Mini 2, they'll have some adhesive here. This one doesn't, so I don't want to give any false pretenses that this is a very straightforward repair to open up. This one's already been pre-opened up. Now we have our screws that hold the EMI shield or heat shield. This protects the logic board and the LCD from each other. And now we have one more shield that holds the LCD and digitizer and battery together. And before you remove anything, unplug the battery first. It's very common on the iPad mini and Mini 2, even the iPad Air, to blow the backlight fuse or backlight circuit of the iPad if you leave the battery plugged in when you remove the LCD cable. Alright, so that looks good. And yes, on this model, we won't have to remove the logic board. The charge port's right here, so we'll be able to do all this in the frame without removing the logic board. And it looks like the LCD and the digitizer haven't been removed before. They're on there still pretty snug. With those detached, we'll set them to the side. Actually, we will need our screwdriver just a little bit longer, so I'll leave that out. Cool, so this is what the inside of our iPad mini looks like. And this one spot right here looked a little suspicious, but it's fine. So that's okay. So now we'll have to remove our charge port, and the charge port has some adhesive. We're not going to be removing the charge port at this time. We're going to be prepping it for removal, because we do have to desolder the solder points on the original charge port. But we have this adhesive right here that's covering what I can only assume is a ground connection. So we just gotta remove that and peel that to the side. And then we have some screws holding down the lightning port connection of the charge port. And underneath the screws here, you will have like a gasket, just a little O-ring. So we'll need to remove that and set it aside so we can put that back on. Alright, with that out of the way, we'll have to bend up these connections where the O-ring was. This also looks like this is like a copper, like a ground. As I'm looking at it, that may be what controls the audio. And there is a piece of black tape right next to the charge port that is going to have to be removed. That is covering two hidden screws. And they're screwed into the charge port at a 90-degree angle. There is corrosion on this side of the board too, of the charge port, so I'm going to have to get a different screwdriver so we can remove those screws, because they look like they may be corroded or rusted in their threads. There we are. There is some rust on the screws that are here at a 90-degree angle. That would make sense. Our corrosion is on the charge port and on the back side of it too. That should be everything we need removed. And the charge port, to make the screws and the adhesive on top even better, their charge port is actually adhered on to the frame. Yeah, so we will address that momentarily. What we'll do is we'll apply some heat using our heat gun to make the adhesive underneath malleable. And let's go ahead and start working on the charge port itself. So the charge port has some adhesive covering the pins. And we will remove that so that we can get ready to desolder the charge port. So let's switch over to our microscope camera. And here's a better look at our charge port. what I'm going to do is turn at a 90-degree angle. And I'm going to cover the battery with a silicone mat I have here. So as we apply heat, we won't be heating up the battery. So what makes this repair a little tricky is we have to be delicate with the charge port as we're lifting it up. There's adhesive underneath the port right next to the pins, and if we start heating it up with our rework station, if we start lifting up too early, there's a very high potential chance to remove the pins that the port is soldered onto. So we're going to do a couple of different methods here. First, we're going to take some new solder and just go over the current pins to get them some new solder on there so it'll melt easier. Whenever we're doing anything solder related, we will need some flux, and we're going to put just a little bit for now, and we'll use a generous amount momentarily. So we have our flux, and just get a good mound onto your solder tip. Just go back and forth until every pin is shiny. Just like so. Okay, now that that's heated up, we'll take our rework station. We're going to use a lower temperature so we don't melt any of the plastic FPC connections right above the charge port right here. That's going to be our digitizer and our LCD. We want to leave those alone. And you can take some Kapton tape and cover that as well. As long as you're not using heat that is over, in this case, I'd say 325. If it's over 325 degrees, then you risk the chance of melting the FPC connections. But we're not using that high of a temperature. So what we want to look out for now is as we're heating it up, the solder is going to be a matte color, or it's not as shiny. So as we're heating it up, it's going to turn shiny again. And that's an indicator that the solder has melted and is ready to separate the charge port from the rest of the board. And I'm going to put some more flux on this guy as well. And we want to go back and forth. We don't want to stay in one space. We want to evenly heat up the entire charge port as a whole. And I can see the solder is attempting to liquefy. I'm going to crank up my heat a little bit more. And I see that some of the pads down here are beginning to melt. And we don't want to start lifting up on the charge port until all of the pins are shiny. And this one right here is not liquefying like the rest of them. Just to be safe, I will add more flux. Okay, so all of our pads are now shiny. I'm going to take my tweezer and go underneath, and I'm not lifting up with a lot of pressure. Okay, so at this point, I'm going to crank up my temperature just a little bit more and apply some more flux. And while I'm at it, I'll actually put some more solder on those pads to tin them up some more. We have a solder ball up here that's trying to run away. There we go. Alright, so I'm not lifting up with a lot of pressure. I'm just going through and heating up the entire pad, the entire charge port, as I just gently slide my tweezers underneath. Beautiful. So we have removed our charge port. We just have a little bit of adhesive underneath that is holding the charge port down in place. So now with our charge port desoldered, we'll have to end up removing the rest of the charge port. And now that we have desoldered this part, we can just start peeling up. And this is malleable just because we were using our rework station, so this is very easy to remove now. Almost done. we have a rubber spacer right here that's holding a Wi-Fi antenna down. You're going to lift that up so we can slide our charge port out. So here's the old charge port. Now we're going to get the new charge port and solder it back into place. So the replacement charge port, and just like the adhesive on the old charge port, we're going to peel this off so that we can place this in its designated area. Let's put it underneath our Wi-Fi cable right here. Awesome. And what I'm going to do before I lay this down to apply pressure to the adhesive, I'm going to go ahead and screw in the holes. Screw in the screws into their designated screw holes for this repair. Oh, that's right, these screws are rusted, so I have to use a different screwdriver. Now we had some spacers that we're going to have to put back. And then we can put the screw down. So our charge port is now screwed in. So with that said, we can bend our charge port to go into the right orientation so we can prepare to solder it back down. And just want to copy how this one laid down. Looks like it just laid down pretty straight actually. And let's go back to our microscope camera so that we can continue lining up the rest of the port. The charge port itself, the replacement one, and the original one, you have these little transparent squares, and they're alignment placeholders. And so we should see these guys, these little squares right here, through the transparent or translucent little lining holes, and this will just make sure that we solder our connection in the exact same orientation it was meant to be. And it looks like that we are relatively high, and that could have been just because I installed the charge port first rather than soldering it first. And let's see, looking at the original charge port, it's actually bent right here, so if we apply some pressure we should be able to bend this down. Almost there. See if we can slide down the charge port as a whole. So I think it's just not laying down all the way. I think that's my fault too. Okay, so I can see this square right here in the top is lined up. Let's look at the bottom. Bottom's lined up too. So we had the positioning of the charge port correct. Now what we'll have to do is remove our leftover adhesive, and we're going to wick up the existing solder off of the pads so we can put some new solder. And it looks like the adhesive has hardened up, but it's not giving us any trouble. It's coming off fairly simple. All right, let's wick up those old pads. Pads have been wicked. We'll take a Q-tip with some isopropyl alcohol to clean up the existing flux. Now we'll apply some new flux in its place. And we'll use this so that we can make new solder mounds. So we're going to run a new bead of solder over these pads. So we are ready to solder on the replacement charge port. So we're going to line up our squares that we had. And this one would have been a little bit easier if we soldered on the connection first before we put in the charge port. That's fine, this will still work. Alright, so our squares are lined up. And what I'm going to do just to cheat for now, I'm going to hold down the bottom part of the charge port and then take my iron and just dab it really quick at the top. That didn't go according to plan. Let me hold it here. There we are. And the bottom's lined up too, so we'll dab that real quick. And the reason that came out so ugly is because we didn't apply any flux. So what I did is I just quickly went over the charge port, just touching up the bottom part of it. Now what I'm going to do is apply some more flux, and like before, we're going to put a bead of solder on the tip of our iron and go over the connections, just to clean this up. And then the last step I do to ensure that the connections are soldered on correctly, I'm going to switch over to my micro pencil and touch up each individual pad. So what I will do here is I'll take my micro pencil and I will touch with my tweezers around this pad and then use the micro pencil to push onto the pad itself. I'll put as well. I'm going to do that for each individual pad. Let me get some more solder on the tip of my iron. And I'm just touching up these a little bit more down here. Okay. Those look nice and touched up. And to clean it all up, we'll take some more isopropyl alcohol and a Q-tip. Okay, we're back. We just had a little bit of technical difficulties there for a second. So our soldering job is done. We've already went ahead and cleaned it up. And now we're going to put our adhesive back on. And then we'll hook it up to our USB ammeter just to make sure that everything is working as it's supposed to. And let's go ahead and plug in our digitizer and our LCD. So if this is charging, this will show a battery icon. Now I'm assuming this is going to take a while to charge because if the charge port has been corroded and not charging, the battery is probably really depleted. And for safe measure, we're going to put the covers back on. This will just limit any potential chance of the LCD or the digitizer disconnecting while the battery is plugged in. And we'll worry about the heat plate once we know that this charge port repair was successful. Because we'll have to take the LCD and the digitizer out anyway, so we can apply some new adhesive. And let me grab my USB ammeter. And see what we get. We get 0.03, 0.4, 0.5, 0.6. So we are charging and we have a battery logo. So that was it. That was a successful charge port replacement. So I'm going to have to give this one some time for it to fully charge up all the way, and then I'm going to do a quality control test. But that kind of shows the process of diagnosing a charge port failure and replacing it. Again, you don't want to replace the charge port if the iPad itself is not turning on, because that could also be associated to a bad battery or potentially a bad charging circuit. In this case, there was corrosion in the charge port, and the charge port did have some damage. One of the pins wasn't going down all the way. So by soldering on a new charge port, we've resolved the issue. It is taking a charge. Our USB ammeter is now showing it's drawing 1 full amp, and that's it for now. I'm going to do all the boring stuff and close it up, and I hope you've liked this. We'll see you in the next one.